ahead and make a start. So, good morning guys, and thank you for joining the webinar again this morning. Great to see so many of you attending, so thank you for that. This is Grant Davidson here. I'm a Senior Applications Engineer here at TMS, and joining me today we have a very special guest actually. That is Chris Burwood, who's joined us for a week during his work experience. So it's been really good to have him in the office helping out. And Chris also, he currently attends his local school, but also happens to be what we believe to be the youngest certified SOLIDWORKS associate in the UK. So very lucky to have him along, and he'll be doing a bit of presenting for you guys this morning as well. It's all really good. So today Chris and I are going to be showing you guys some advanced assembly techniques. Now, I thought this was a great opportunity to cover this, as 2016 is bringing with it some great enhancements to assemblies, and I thought it'd be really good to cover those tools that we maybe don't use so often, but do warrant a bit of highlighting. So let's go ahead and get started this morning. So opening here in SOLIDWORKS 2015, it's probably soon to be 2016. But let's consider a scenario like this. So we've got a reasonably complicated little assembly, and we're looking to mate all our components together. Now, I know that I want to add in concentric mates between all these circular faces in my through hole there, so I could select them all individually, but what I could also do here is use what my mouse cursor is hovering over at the moment, which is the multiple mate mode. Now, if I click multiple mate mode, what it allows me to do is go ahead and choose a common reference. So in my case, this through hole that we've got in the component here, and then in the other dialog for the component references, all I need to do is go ahead and choose the circular faces on every other component. So really easy. Go ahead and select your components. If we do happen to select one and the reference is round the wrong way, we can go ahead and flip it using the little contextual flyout we get for the mate dialog. We'll do the final component now and finish off this process. Next, what I'm going to do, a little bit more work on this one. We'll add in a few more mates just to make the assembly that bit more realistic. But you can see here that I've got a multi-mates folder under my mates dialog, and all my mates are contained in there. And no different from any other mate, we can always go in, edit it, make adjustments as need be. But as I say, let's go ahead and do a bit more work on this assembly. We're looking to get it a bit more realistic, so we'll bring this out. And what I would eventually like to achieve here is a scenario, or possibly a mate type being used, that keeps this plunger within the housing. But we'll see about that. Maybe Chris can help us out there. So let's make this handle up together, and this red cap that we've got on the end here, let's go ahead and get that mated onto the end of the main body component. Now, as I say, next here, guys, if I go into an appropriate view here, what we'd like to do is make sure that this plunger cannot exit out of the tube which it's meant to stay within. Now, in order to do this, we're going to use the width mate, a tool which people maybe don't use in other ways so often, but we're going to make use of it here to go ahead and keep this plunger inside this housing. Now, me personally, I have no idea how to do this. However, it just so happens we do have a man who does know how to do it. So I'm going to pass over to Chris here, who's going to give us a bit of a hand and show us how we can utilise the width mate in order to make this happen. So over to you, Chris.
Thank you, Grant. To use the width mate, first we need to go up to our mate dialog box, go to our advanced mate section and click on width mate. Under the width mate, there is more than one option under the constraint tab. There's centered, there's free, there's some dimension, and there's percent. But for this, we're going to use free later on. The most commonly used one will be the centered, which allows you to put a part between two faces. So going up to our mate dialog box, advanced mates again, and width, we're going to use the constraint. Under the constraint tab, use centered. All we have to do is select the two faces we would like the part to be put between, and then another two faces that the part is going to be centered between. As you can now see, the part is perfectly centered between these two faces and now rotates rather than moving sideways. For this one, rather than using a centered width mate, we're going to use a free mate. This will allow it to not come past that red cap and will make it more realistic to a real world scenario. All you have to do is select the first two faces of the plunger, and then in your second tab selection, select the faces that you would like it to not come past after selecting free. If you do not do this, it will then become centered around that and it will not be able to move. If we say OK to that, you can now see as we slide the plunger up and down the housing, it does not come past the cap. Back to Grant.
Okay, so thanks Chris. WithMate, a great flexible tool with a lot more uses than I'm sure a lot of us actually realise. So yeah, thanks for that Chris. Okay, so here's another great one for you guys. I have got a little spiral staircase model here that I'm looking to complete. Now, it's not going to be as simple as just going ahead and copying my components and pasting them into place, because I've got several different mate types in here. I've got concentric mates between the shaft and the step itself, and I've also got coincident distance mates in there as well. So how am I going to be able to do this in an efficient fashion, rather than having to remodel and remate? Well, we've got a really good little utility for this, and if I go ahead and use my search bar, because it's not found in the assembly tab, it's copy with mates. Now, if like me, you do quite like this tool, you see yourself using it a bit more often, go ahead and grab hold of it, drag it over and drop it into the assembly taskbar. That will give you quick access for future. Now let me click on that and just choose the components I would like to copy here. So I'm going to choose the step, and I'm also going to choose the yellow spacer in there. Let's click on next, and under the mates dialog here, gives me the option to just do a complete carbon copy of the mate using the repeat dialog, which I do want to do for my first two concentric mates, because that's just the hole in the shaft and the step. However, my coincident one mate, this is the mate for the first step, which defines the distance from the bottom of the staircase. So I don't want to use the bottom face for the reference, I would rather use the top face of my first step as the reference. So I just need to choose it, and SOLIDWORKS will take care of that for me. Now for concentric 3, this is to do with the holes in the base that you see. So if I select the next one round, I can get that spiral effect happening. You can see there, literally 30 seconds guys, and we've got all our mates copied over, we've got our components copied, really that simple. And if you want to add more, it's just a case of redefining those references once again. So really easy, quick to do, and it really is a great tool. Give this one a go for yourselves, certainly guys. And to exit out of there, just use the little X on the copy with mates dialog. Have a look at the tree, you can see all the mates have been added in. Again, nothing fancy about them, they're not uneditable, they're not mysterious, they are just standard mates that can be edited. Next up guys, a little treat for you here, some mechanical mates, using this little machine that we've constructed. Now the first one that I would like to show you guys here is the rudimentary gear mate. Now obviously I've got two pulleys in my design here, I want them to turn in unison basically. Now one way I can achieve this is just by using the gear mate. Really simple to use, quick and easy. All I need to do is go ahead and choose two reference edges, faces, vertices, whatever I would like to choose, and SOLIDWORKS takes care of the rest. You can see that it will automatically apply my gear ratio based on the entities that I've selected, and I could choose to reverse that if need be. Now when I grab hold of one of my pulleys, you'll see that the other one moves in unison with it. So yeah, a great tool, really good, and as I say, nice and quick to do. But to be honest, not all that realistic in the case of my pulleys here, because we would really ideally have a belt going between them. So what I can do is go ahead and delete this gear mate out, suppress it out, or just get rid of it by some means, and I'm going to go ahead and use an assembly feature here of the belt. Now if I choose my belt chain feature, again, really easy to use. All I need to do is select those same entities once again, and we get a preview of the belt that SOLIDWORKS is constructing for us. Now at the moment, that belt is pointing outward. We can apply a thickness to it if we want. However, we've got a slightly bigger problem than that. Due to the distance between these two pulleys, you can see what I'm highlighting with my mouse cursor there. It equates to having a belt of 2033 millimeters. Now, trying to get that off a supplier is not going to happen very easily. So what we can do instead is click on our driving button. This will allow us to drive the length of the belt, and the design will adapt around that. So we're going to make that 2000 millimeters there. And we'll also choose to create a belt part. Now, it'll become a bit more apparent what this does in just a few moments, but for now I'm going to select the create belt part feature also. I'll click OK. It adds my belt in. As we can see, you can see that arm has moved upwards slightly to accommodate the 2000 millimeter belt rather than the 2033 millimeter belt, and the design's looking great. If we cast our attention over to the tree for a moment, you can see we've got belt 2 in here. If I expand that out, you can see in there that I've got a fairly standard looking part file, which I can open, and I can apply any feature to it that I want. It is in essence just a sketch at the moment. So we could go ahead and extrude that out, maybe apply a rubberized textured material to it, make it look like a belt. In this case we won't bother because it's fairly straightforward to do, but it's certainly all possible. Just add that next level of realism to your design. Now the final mate we need here, well, second last mate, apologies, is the slot mate. So a classic slot mate wherein we want to get that slot action between the cut I've got in this this handle here, and also the little red knob that I've got on one of my pulleys. So I'm going to click on the slot mate, which is found under mechanical mates. Again, various different constraint settings in there. Have a look at them yourselves, guys. But for now, we're going to stick with the free mate. Really simple to use. Just need to choose the slot itself. You can see all tangential edges are highlighted. Choose the little knob that I've got on the pulley there, and it goes ahead and adds them in. And now, if I move my assembly, you can see that we get that classic slot movement. So again, really easy to add, but quite a powerful tool by any account. Now, the last mate that we're going to need to add in, last mechanical mate, is going to be for this cam component here. You can see I've got my cam follower just sat above it, and I've also got the cam. Now, for this one, I'm going to pass over to Chris here, who's going to take you through using the cam mate.
Thanks, Grant. To add a cam mate, first we need to select the mate and go to mechanical mates. And select cam, which is at the top. In your first selection, you need to select all the faces that are on your cam. It is crucial that you select all the faces for this mate to operate correctly. You can orientate round your views to make sure you can get all the faces selected. Get this final face here. And for your cam follower, all you need to do is select this small wheel, which will then, after selecting its face, will bring it down in contact with the cam. If we say OK to that, and then we reorientate ourselves to an appropriate view, you can now see as we rotate the cam round, the wheel follows the cam, staying in contact with its face at all times. Back to Grant.
Alright, so thanks once again, Chris. Great looking assembly there. Okay, and that brings us on to the final assembly techniques of today, guys, to show you. And what we'd like to take you through here is some selection tools and some smart fasteners. So let me give you a demonstration. So if I drop down my little cursor button in my top pane here, you can see that I've got various selection tools available to me. A lot of people don't even realise that there are different selection tools, so let me take you through a few of them here. One of my favourites is this one here of volume select. Now what it allows me to do is go ahead and draw in a bounding box, just as always, but that then turns into a volume that I can use my manipulation arrows to go ahead and include what I want and exclude what I don't want. So a really quick selection tool for those intricate assemblies. Another good technique is if you right click and go ahead and use the invert selection, it completely flips the selection of your tools, of your components there. So great tool, that one. Next we've got select by size. this is a good quick tool. Again, maybe more so on those intricate assemblies where you have little nuts, bolts, fasteners, that sort of thing. SOLIDWORKS will allow us to go ahead and choose parts of our assembly based on the size. So again, really powerful quick tools, guys, and there are more in there. Unfortunately, we don't have time to cover them all today, but certainly have a look for yourself. Now, next up then, guys, what I would like to do here is have a look at some smart fasteners. Now, as you can see, I've got some holes in my components here. And what I would like to do is get some fasteners into these, some appropriately sized screws, and some on the other side, some screws, nuts, bolts, washers, that sort of thing. Now, smart fasteners is a little used tool, and what it does for us is actually really powerful. It will automatically find and place the correct toolbox fasteners based on the holes in your model. It's found just where you can see my mouse cursor right now. Let me give you a demonstration of it. So if I go ahead and click on my Smart Fastener button here, choose the face and just click on Add, just like magic, we go ahead and we get our fastener components added in. It's all completely editable, but SOLIDWORKS does a great job of selecting the correct one from the outset, so we don't really need to do much work there at all. Let me repeat that process once more, wherein we'll choose this face, click on our Smart Fasteners, and you can see once again it's went ahead and added them in. However, in this case, I would also like some washers and some nuts on the end of these bolts as well. So if I scroll down, you can see that we've got a bottom stack column, and in this bottom stack, if I choose to, I can go ahead and put in a regular flat washer. We'll see that be added in, and I would also like to add in a hex nut. Let's go for style 1 here. You'll notice as well that it automatically extends the length of the bolt to an M5 bolt to account for these additional fixtures that we've got in there. Now, unfortunately, guys, we have used up all the time available today. However, we do have something very exciting for you. SOLIDWORKS 2016 is almost here, and in order to show you guys a little bit about it, we are doing our annual rollout events. That's where you can come along and you can be introduced to all the new features of 2016 by myself, one of my applications engineers here at TMS CADCentre. And we're also going to be joined by someone from SOLIDWORKS as well, who's going to be doing a little bit of presenting side by side with us. It's a really enjoyable morning. It's on until 12 o'clock. I think there may even be a free lunch in there somewhere. And we're going to be in Glasgow, Edinburgh and Aberdeen. So we're trying to cater for everyone here. Glasgow is going to be on the 20th of October, Edinburgh on the 21st of October, and Aberdeen on the 22nd of October as well. So we really hope to see you guys there. If you would like to come along, get in touch with us. You can drop us an email, you can register on the website, or you can just give us a call in. We'd love to see you there. We'd love to show you the new tools. We're really excited about it. So yeah, be great to have you along. But for today, and indeed the webinar, we are finished. So from both Chris and I, have a fantastic weekend, guys, and we'll catch you on the next one. Cheers.